Hello everyone, this is Chris. Today I'm gonna give you a small R video talking about the CLT. Okay, here in the probability theory, the CLT states that given certain conditions, the mean of a sufficiently large number of independent random variables, each with a well-defined expected value and a variance will be approximately normally distributed regardless of the underlying distribution. Okay, remember this will appear on the test. Okay, back to R. Same as before, these are all the code that I will use in this video. And first, what we want to do is to create a large number of independent random variables. So let's say the name of it, the data is A, and then we have a matrix here. Here I created a million of random variables which distributed in a uniform distribution, but that's not enough. What I'm gonna do is I want to add something. I want these random variables to the power of 1/3. Then we're gonna have 1 million random variables which fall in a distribution that is uniform distributed but to the power of 1/3. This is not a common distribution you may see on the textbook or something else, but what I'm gonna prove is even though a distribution like this, if you have enough large numbers of these random variables, and obviously here all the random variables are independent. If you calculate their means, you're gonna have a normal distribution. Okay, for this 1 million variables, I'm gonna give them 1,000 columns and 1,000 rows. Okay, look here. So we're gonna have a large matrix, 1,000 by 1,000. Okay, then we're gonna have a data B. Here we use an apply function to calculate its average, calculate its mean. So the three important arguments in this apply command is the first, where to apply. The second, you want to apply the rows of the data with the columns of the data. The third and the most important is what function you want to apply. Okay, first I want to apply the main function to the data named A. Then I want to apply to each row. I want to calculate a mean of this row. So the function is mean, so I want to calculate the mean of each row. So after doing this, here I'm gonna get a value called B. That is it's a bunch of numbers. Actually, it's 1,000 numbers. All these numbers are means, are averages. What I'm gonna prove is all these averages, all these means are approximately normally distributed. So I'll plot them out using the histogram. So I want a histogram B, and I want the density, so the frequency equals force, and breaks, let's say the breaks, let's say the breaks, let's say 18. So it should be the breaks. Okay, here we get the histogram of B, and then let's draw a line here. describing the density of B. Give it a color. Let's see 2. Let's make it thicker. Okay, here I got a line here. So obviously these all these means are approximately normally distributed, which is exactly the CLT states. The CLT states that given certain conditions, the mean of the sufficiently large numbers. So here we have 1 million number of independent random variables. These are independent random variables will be approximately normally distributed regardless of the underlying distribution. Here is normally distributed. It's approximately normally distributed. Okay, that's today's video. Thanks.